Alright, Chapter 10, Section 3, Related Processes. Plasma arc cutting. General plasma arc cutting process for the cut metal by melting sections of metal with a constricted arc with a high velocity jet flow with a hot ions gas metal with the metal. Remove the molten metal material to form a curve. The basic arrangement of this plasma arc cutting torch, similar to the plasma arc welding torch as shown in figure 1071, the variation of the process exists: low current plasma cutting, high current plasma cutting, cutting with water added, low current with a cut arc cutting which produces a high quality cuts of thin materials. Use a maximum 100 amps of the and much smaller torch to higher current conversions. Modification and process equipment has been developed to permit the use of oxygen in original orifice to allow the efficient cutting with the steel of the plasma torch. All plasma torches constrict arc passing by it through orifice travels away from the electrode toward the workpiece of the orifice. Gases pass through the arc is heated rapidly. High temperature expand with the accelerator with the pass through the constriction orifice. The intensity velocity of the arc plasma gases are determined by such variables: type orifice gases entrapped, and pressure constricted with the orifice shape, diameter of the plasma, energy density of the work. 1071 shows the plasma arc torch terminology, starting with electrode orifice constriction nozzle, plenum, electrode setback, constriction orifice diameter, work torch standoff distance, orifice throat length, shielding gas nozzle, shielding gas. This shows a typical analysis of mechanical properties of submerged arc weld, flux core wire combinations. Equipment. Plasma cutting requires the torch and control unit with a power supply. One or more cutting gases supplied with a clean, cooling water. Equipment is available in both manual and mechanized power plasma arc cutting. Cutting torch. Cutting torch consists of the electrode holder with the center of the electrode tip with respect to the orifice of the constricting nozzle of the electrode, and nozzles are water cooled to prolong the life of the plasma gas. Is intended for the torch around electrode exists for the nozzle orifice. If the nozzle varies, all orifice diameters are available to each for the type of the orifice. Your orifice diameter depends on the constant cutting current. Large diameters are required to a higher temperature for the normal nozzle design. Depends on the type of the plasma arc cutting of the metal, beginning with a cut. Um, Both single and multiple port nozzles may be used with the plasma arc cutting. Multiple port nozzles, auxiliary gases arranged with a circle around the main orifice. All of the plasma gas passes for the main orifice. The high gas flow rate per unit air the nozzle produced for the better quality. Cut single port nozzle at the equivalent travel speed. However, the cutting quality decreases with the increase of the travel speed. With the total design, introduced shielding gas welded around with a plasma flame are available. Plasma arc cutting torches are similar to appearance of the gas tungsten arc with the electrode holders, both manual and machine type of the mechanized plasma arc core. Arc torches of the mounted with the shape of the cutting machine, similar to the mechanized oxy-fuel gas shaping cutting equipment. Cutting may be controlled with the photoelectric tracing and numerical control of the computer. Controls console with the plasma arc cutting may be solenoid valves to turn gases, cooling water on and off. The usually flow meter of the various of the type of the cutting gases used with the water flow switch for the top of the operation. Cooling the water falls below the safe limit of the control of the high power of the automatic plasma arc cutting may also contain programming feature upslope and downslope of the current orifice gas flow. The power sources of the power and plasma arc cutting are specially designed units. Open circuit voltage ranging from 120 to 400 volt. The power source is selected on the base of the plasma arc cutting torch to be used. The type of the thickness of the work and metal with the cutting speed range with the voltage amber output characteristics must be typically drooping type. Heavy current requires heavy high open circuit voltage for the capability of the piercing metal within as thick as 2 inches with the low current manual cutting equipment with the use of the low open current circuit voltage 100 to 200 volts. Some power sources have the connection necessary to change the open circuit voltage required for specific applications. The output current requirements range from 70 to 1000 amps, depending on the material thickness and current or speed, but the unit may also depend containing on the pilot arc high frequency power source circuitry. Alright, your gas selection. Cutting broad gas selection depends on the material being cut. The cut with the surface quality requirements of non-ferrous metals are to be cut using nitrogen, hydrogen mixtures, argon, hydrogen mixtures, titanium, zirconium. Carbon steels are be cut by using compressed air, 80% nitrogen, 2% oxygen. Nitrogen plasma arc. Nitrogen is used with the water injection method of plasma arc cooling. Some systems with nitrogen plasma forming gas, oxygen injected with the plasma downstream of the electrode with the arrangement of prolonging the life of the electrode not existing in oxygen, not exposing it to the oxygen. For some non-ferrous cutting, the dual fuel system nitrogen for plasma gas, carbon dioxide for shielding for better quality cuts. The argon, hydrogen plasma cuts and nitrogen shielding are used. Principal operation: basic plasma arc cutting circuitry shown figure 1072 with the process of operative with direct current, straight polarity, electrode negative with the constricted transferred arc with transfer arc mode. The arc struck with between the electrode in the torch of the workpiece. The arc is initiated by a pilot arc between the electrode and the constricting nozzle. The nozzle is connected to ground and not positive through the current limiting resistor pilot arc relay to the ground. Contact the pilot arc is initiated with a frequency generator connected to the electrode nozzle with a welding power supply with a maintains low current arc inside the torch. The ionized orifice gas of the pilot particle blown and through the constricting nozzle orifice forms a low resistant path to ignite the main arc between the electrode and workpiece. The main arc ignites the pilot relay may be open automatically to avoid unnecessary heating of the constricting nozzle. Alright, 1072 shows the basic plasma arc cutting circuitry, power resistor, pilot relay, contact, high frequency generator, electrode constricting nozzle, and work. Alright, with cutting pure orgone because of the susceptible embrittlement reactive gases, basic plasma cutting nozzle exposed with a high plasma flare temperatures, basically 10,000 to 14,000 Celsius. The nozzle made of water-cooled copper in addition with the torch should be designed to produce the boundary layer of the gas from the plasma and the nozzle. Some of the unprocessed variation of the plasma arc cutting quality, particular applications are generally applicable to materials 1/8 to 1.5 inch thickness range. Auxiliary shielding is form of the gas or the water is used to improve the cutting quality. Dual flow plasma cutting. Dual flow plasma cutting provides a secondary gas blanket around the arc plasma, shown figure 1073. The usual orifice is nitrogen. The shielding gas is selected for the material to be cut for mild steel with the carbon dioxide in the air, or air, stainless steel, carbon dioxide, argon, hydrogen mixture for aluminum. For mild steel, setting speeds are slightly faster for the conventional plasma arc cutting, but the quality of the cut quality is not satisfactory for many applications. 1073 shows the dual flow plasma arc cutting, electrode orifice or constricting nozzle workpiece, shielding gas nozzle. Water shielding plasma cutting, the technique with similar dual flow of the plasma cutting used in place of the auxiliary shielding gas. Cutting appearance and nozzle life are improved with using water in place of the gas. Auxiliary shield with the cut squareness and cutting speed is significantly improved with the conventional plasma arc welding cutting. Water injection plasma cutting, the modification of the plasma arc cutting process is symmetrically impinging water jet near constricting nozzle or if it's further constrict with the plasma flame in the arrangement shown figure 1074 with the water jet with the shield of the plasma mixing with the surrounding atmosphere. The end of the nozzle made in ceramic help to prevent double arcing. The water constricted with the plasma produces a narrow, sharply defined cut at the speeds above through those conventional plasma arc cutting. Because most of the water leaves the nozzle as a liquid and spray cools the curved edge, producing a sharp corner of the curve is clean. When the orifice of the gas and water injected with the tangent of the plasma gas swirls it emerges from the nozzle and water jet that can produce a high quality perpendicular face on one side of the curve and the other of the curve is beveled. In this shape of the cutting application direction travel must be selected to produce perpendicular cut to on the part and the bevel cut on the scrap. Orifice gas swirl, electrode constricting nozzle, water inlet chamber, ceramic insulator and work show the water injection plasma arrangement. For high current cutting, the torch mounted with a mechanical carriage, automatic shape cutting can be done with the same equipment used in oxygen cutting and sufficiently high travel speed with the tandem of the water spray using surrounding plasma to reduce smoke and noise. Work tables contain water with contact underside of the metal being cut with it reduce the noise and smoke. Plasma cutting torch can be used in all positions. It can also be used for piercing holes for gouging. Cutting torch with special design. Cutting is not used for welding. Metals usually cut this process with aluminum, stainless steel. The process can be used with the cutting of the carbon steel with the copper alloys and nickel alloys. Special controls are required to adjust both plasma and secondary gas flow. Torch and cooling water is required with a monitor and pressure flow switch is for torch protection. Cooling system should be self-contained with the includes circular pump and a heat exchanger. Plasma arc cutting torches will fit the torch holders and automatic flame cutting machine. Amount of gas is timed. The generator requires you with the local exhaust, proper ventilation. Cutting shield will be done over a water reservoir so that the particles removed from the cut will fall in the water. This will help reduce the amount of fumes released in the air. The application of the cutting of the cutting any of the metal. Most application with carbon steel, aluminum, stainless steel can be used for stacking, plate beveling, shape cutting, and piercing. Alright, warning for air protection must be worn with working with a high powered equipment. The most the noise level generated with a high powered equipment, the uniform uncomfortable. The cutter must wear air protection. Normal protective clothing protect the cutter from the arc must be also be worn. This involves the protective clothing of gloves and a helmet. The helmet should be equipped with a shade number 9 filler grade lens. There are many applications of lower current plasma cutting, arc cutting, including cutting stainless steel aluminum production, maintenance of the plasma cutting. They can also be stack cutting and the more efficient stack cutting with the oxyacetylene torch. Low current plasma gouging can be used as an upgrading case castings. Alright, 1016, your air carbon arc cutting. General air carbon arc cutting is a cutting process which melted with the heat of the carbon arc. The molten metal was removed by the blast of the air. The method of the cutting removed the metal with the melting it with an electric arc, the blowing away of the molten metal with a high velocity of jet compressed air. The air jet is extremely consumable to carbon graphite electric strike with the molten metal with it immediately behind the arc. Air carbon arc cutting and metal removal differ from plasma arc cutting with the employ an open unconstricted arc with independent of the gas jet with the air carbon arc process shown in figure 1075. 775 shows the process diagram of the air carbon arc cutting a handhold carbon electrode direction travel air stream workly base metal. The circuit diagram for the air carbon arc cutting gouging is shown by the figure 1076. Normally conventional welding machine with a constant current. Use constant voltage can be used with the process using constant voltage power. The precautions must be taken to operate it with a rated output of the current and duty cycle. Alternating current power sources have conventional drooping characteristics, can also be used with special applications. AC type carbon electrodes must be used. Shows base metal work electrode, polarity electrode, lead carbon electrode, handhold electrode, compressed air power source. Figure 1076 shows your air carbon arc cutting diagram, air outlet holes, air valve, upper level valve, power line, air line. Equipment required shown with the block diagram. Special heavy duty high currents are made of specifically air carbon arc process because of the extremely high currents of the large side of the carbon electrode. Electrode holders are designed for air carbon arc process with the ability to include small circular grip line. Grip head contains air jets directly compress air for them along with the electrode, and it has a groove for gripping the electrode. This head can be rotated allow different angles of the electrode with respect to the hole. The heavy electrode lead and an air supply hose connected to the holder through the terminal block of the valves included with the holder through the turning compressed air with the on and off and holders available to several sides depending on the duty cycle of the work performed. Welding current and size with the carbon electrode. Use heavy duty work with the water cooled holders are used with the air pressure critical and should range from 80 to 100 psi volume compressor. The required ranges from 5 cubic feet up to 50 cubic feet per minute. For a large size carbon electrode, 1 horsepower compressor will supply sufficient air. For a smaller size electrode, it will require up to 10 horsepower compressor while using large size electrodes. Alright, your carbon graphite electrodes are made with a mixture of the carbon graphite and then plus with a binder with a produce homogeneous structural electrodes continue several types. The plain uncoated electrode is less expensive, it carries less current, but the start's easier. Copper-coated electrode provides with better electrical conductivity between it and the holder. The copper-coated electrode with maintaining the original diameter of the operation longer carry with a higher current with the carrier. Copper-coated electrodes are 2 types, DC and AC type. The composition ratio of the carbon and graphite is slightly different than those of the 2 type. Of the DC type is more common. The AC type of the special elements to stabilize the arc. The different current electrode negative will cuts cast iron. Normal UV electrode is operated with electrode positive. The electrode ranges diameter from 5/32 to 1 inch. Electrodes are usually 12-inch long, and however 6 inches of electrode are available. And copper-coated electrodes with tapered socket joints are available to operation, allowing continuous operation. Figure 1025 show that the electrode type of the arc current range from the different sizes. Electrode type and sizes current range. Our advantages and major uses. The air carbon arc cutting is used with a cut with the metal with a gouge out with the defective metal with the remove of the old inferior weld with the rope gouging and the full penetration weld to prepare with the grooves for welding. Air carbon arc cutting is used with slightly ragged edges are not objectionable. They are cut in small sections metal with the metal to remove quickly. Surrounding area does not reach high temperature to reduce the tendency toward distortion cracking. The air carbon arc cutting gouging process is normally manually operated with the apparatus can be manual with the travel carries considerable machine cutting and the gouging. Special applications have been made with the cylindrical work that have been placed in the lathe-like device rotated with the air carbon arc torch. This machine automatic cutting, depending on the automatic improvement, the air carbon arc cutting process can be used in all positions, can be also used with the gouging in all positions, used with the overhead position required with a high degree of skill. The air carbon arc cutting process can be used with the cutting and gouging most of the common metals, including aluminum, copper, iron, magnesium, and carbon, stainless steels. The process is recommended with welded penetration stainless steel, titanium, zirconium, and other similar metal materials without subsequent cleaning. The cleaning usually by grinding, which must remove all the strip of the carbonized material adjacent to the cut. The process can also be used to cut the materials for scrap for remelting. Alright, your process principle. The procedure scale for making the grooves in the steel is in the table 1026 and page 10.112. The making the cut into the gouging operation, the cutter strike for the arc and the almost immediately stuck out from the airflow. The electrode is pointed with the direction travel with a push angle with approximately 45 degrees axis for the groove. The speed of the travel of the electrode angle of the electrode side of the current is determined by the groove depth. Electrode diameter is determined by the groove width. Normal safe precautions similar to the carbon arc welding and shield with the metal arc welding applied to the air carbon arc cutting gouging. However, the two other precautions must be observed. The first, an air blast will be covered with the molten metal. Travel with very large metal deflection plates should be placed in the front of the gouging operation. Combustible material should be moved away from the work area. The high current level of the mass of the molten metal removed is quite large and will be fire hazard not properly contained. Second factor is high noise. High currents and high air pressure, very loud noise occurs. The air protection, earmuffs, and the air plugs should be worn by the arc cutter. The process while leave the back gouging, preparing joints, and remove the defective weld. 1026 shows your air carbon arc gouging procedure schedule. Alright, resistant welding. Alright, generally resistant welding is a group of the welding process which can call into with is produced with the heat obtained with the resistance of the work of electric current. The trigger from which the work is part of the application pressure, but there are at least 7 important resistant welding processes. There are flash welding, high frequency resistant welding, percussion welding, projection welding, resistant seam welding, resistant spot welding, upset welding. Your principal process of the resistance welding process differs from all the other previously mentioned, but the filler metal is rarely used. The flexors are not employed. 3 factors involved with making the resistance of the mount of the current over the pass through the work, the pressure of the electrode transfers through the work, the time that the current flows through the work, the heat is generated the passage of the electrical current through resistance circuit, force applied before, during, and after the current through below, force of the heat parts together with the coolancy will occur. Pressure is required throughout the entire welding cycle to ensure the continuous electrical circuit through the work. The concept of the resistant welding is most easily understood with the listing of the resistant spot welding. Resistant spot welding is most popular, shown in figure 1077. High current of the low voltage flows from the circuit and is in accordance with the Ohm's law. Voltage over ohms or voltage over I have the current amperes, E is the voltage, R is the resistance, so you'd have amperes over voltage over ohms, and then ohms equals voltage over amps. Total energy is expressed in formula. Energy equals to amps equal times volts times T, and T is the time and second during the current flows in the circuit. So 1077 shows the resistant spot welding, end of the weld time, electrode welding, temperature, water force, welding, transformer, contactor, AC power, work, water, and force. Combining these two equations for the given the heat energy equals to amp squared times the ohms times the time. For the particular reason, the factor related to the heat loss should be included. Therefore, the actual resistant welding formula is heat energy equals to the amps times the ohms times the time times the heat energy, or K, which represents the loss of the radiation conduction. In this formula, I stands for the squared, and amperes, R stands for the resistant working of the ohms, T is the time of the current flow in seconds, K represents the loss of the radiation of the conducting. Alright, welding heat, a proportional square of the welding current. If the current is double the heat generated, that is quadruple. The welding heat is proportional to the total time of the current flow. If the current is double, the time can be reduced considerably. The welding heat generated directly proportional with the resistance related with the material with being welded with the pressure applied. With the heat loss can be held to the minimum with the advantage of the short welding tire. The maximum pressure for the force of the part put together helps refine the grain structure of the weld. Heat is generated with the contact between the welded electrodes and with the work. The amount of the heat generated lower sense of the resistance between the high conductivity electrode material normally employed with the metal steel is less than between the two pieces of the mild steel. But the most application of the electrodes are water cooled to minimize heat and generated between the electrode and the work. Resistant welds are made very quickly. However, each of the process has its own time cycle. Resistant welding operations are automatic pressure is applied with a mechanically hydraulic pneumatic systems. Motion is involved with the applied with mechanically current control with a completely automatic with the welding operation initiates weld resistant welding equipment utilized with the program or concurrent controlling current time cycle with the pressure movement of the welding programs resistant. Welding can be quite complex in view of the quality of the problems. Welds do not, depending on the welding operator skill, more than proper setup and adjustment of the equipment adherence to welding schedules. Alright, resistant weld is used primarily with the mass production industry. Long production runs, consistent condition of the convenient time. Welding is performed with the operator to normally load and unload the machine operator at the switch, initiating the welding operation. The automotive industry is the major user of the resistant welding process, followed with the appliance of the industry. Resistant welding is used in many industry manufacture a variety of the products that are made of the thin gauge metal. The resistant welding is used in the steel industry with the manufacture piping, tubing, smaller structural sections. Resistant welding has the advantage of producing high volume work at high speed. It does not require filler metal. Resistant welds are reproducible. High quality welds are normal. 8. The position making the resistant weld is not a factor, particularly in welding thinner metal. Sheets shows the welded metal. Table 1027 shows the base weld and the resistant process. Metals are weldable with a thickness that can be welded with the joint. The design are related with a specific resistant welding process. Most of the common metal with the welded with many of the resistant welded process. See table 1027. The difficulties encountered with the welding certain metal within thicker section. With some of the metals require the treatment of the welding satisfactory mechanical properties. Weldability with the control 3 factors: resistivity, thermal conductivity, melting temperature. Metals with a high resistant current flow with low thermal conductivity, relatively low melting temperatures would be easily welded. The ferrous metals are all and fall in the category. Metals that have low resistivity with a higher thermal conductivity likely more difficult to weld. This includes the hot light metals, aluminum, magnesium. The process because of the compromise of the third group. This is the difficulty to weld because of the very thermal conductivity of the fourth group of the refractory metals, which are extremely high melting points, are more difficult to weld. The three operators can be combined with a formula would provide the indicating of the ease of the welding metal. This formula is W equals weldability over the resistivity over the divided by the flux, the melting temperature of the metal in degrees, the C or KT relative thermal conductivity of the copper equal to 100. The weldability below 0.25 in the poor rating. Alright, if W is 0.25 and 0.75, the welding becomes between 0.75 and 2.0. Welding is good, but above 2.0, the welding is excellent. With informal mild steel, would have weldability range over 10. Aluminum weldability factor is from 1 to 2, depending on the alloy. Considering they have a good weldability rating. Copper and certain brasses have a low weldability factor and are known to very difficult weld. Flash welding. Flash welding is a resistant welding process for the produce of the coolant simultaneously over the entire area of the abutting and the shift of the heat obtained with the resistance of the electrical current between the two surfaces by the application of the pressure of the after heating substantially complete with the flashing upsetting of the unaccompanied expulsion metal from the joint. These are shown figure 1078 during the welding operation. The intense flashing of the heating of the metal surface of the budding each of the after the predetermined time. Two pieces are forced together. The joining occurs with the interface of the current flow is possible because of the light contact between the two parts being flash welded. The heat generated with the flashing localized with the area between the two parts of the surface are brought to the melting point exposed through the budding area. As soon as the materials flash away, another small arc is formed continuous until the entire budding surface are melted. Temperature and pressure is then applied and the arc is extinguished and upset occurs. 1078 shows flash welding, finished flash welding, stationary clamp, movable, upsetting pressure, welding transformer, AC power. Alright, flash welding can be used with on metals, non-special penetration with the required, except for the heavy scale of the breath. The grease must be removed with the joints and must be kept square with the provide even flash Uh, weld even flash across the entire surface of the material to be welded with a clamp in the jaw flash welding machine. High clamping pressure of the underside of the pressure of the steel exceeds 10,000 psi. For high strength material, the pressure may be double the tubing of the hollow member's pressure is reduced as well with the area with the more contact upset pressure with the increase of the insufficient upset with the pressure U with the porous low strength weld will result in the excessive upset with the pressure will result in expelling too much weld with the metal with the upset cold weld metal. This may not be uniform with the entire cross-section fatigue. The impact of the string will reduce the speed of the upset with the time of the trim of the end flashing period and the end of the upset period. It should be extremely short with the minimum oxidation of the molten surface in the flash welding operation. Certain amount of material is flashed and burned away. The difference of the jaws are welding compared to the distance from the welding of the zone with the burn off. That can be 1/8 inch thin material up to several inches. The heavy material welding currents are high and are related to the following: 20 kilovolt amperes per square in cross section, 8 seconds. Desirable usable low flash voltage, desired flashing speed, low voltage, normally 2 to 5 volts per square inch cross section of the weld. The upsetting force of it is usually accomplished by means of the mechanical cam application. The design of the cam is related to the side of the part being welded. The flash welding completely automatic. This excellent process for the mass-produced parts requires machine large capacity design specifically for the parts that are to be welded. The flash produces within around the periphery of the weld that normally removed. Alright, friction welding, FARW. Generally, friction welding is solid state with the welding process with the reducing of the coolancy of the material with the heat obtained with the medically induced sliding motion between the rubbing surface of the work parts that are held together under pressure. For this process usually involves the rotating one part against another, generating the friction. Process usually involves the rotating one part against another, generating the friction heat with a junction with a suitable high temperature for the way can be reached. Rotational notation ceases the additional pressure is applied with the coolancy occur, but there are two variation friction welding processes. They are described below. In the original process, one part is held stationary, the other part is rotated motor maintains essential constant rotational speed. Two motors are brought with the contact onto the pressure for the specified period of time. Specific pressure for the rotating power is disengaged for the rotating piece of the pressure is increased for the rotating piece. Stop the welding is complete with the process accurately controlled with the speed and pressure time and closely figured. Alright, the other variation of the inert welding of the flywheel is revolved by a motor with a preset speed with a reach for the turn rotates one piece due the bead weld of the motor disengaged from the flywheel. Other part to be welded brought into the contact under the pressure of the rotating piece during the predetermined time during the rotational speed of this part and the flywheel brought into the immediate stop of the additional pressure is produced the complete weld. Both welds methods are used friction heat with produce the use of similar quality, slightly better control claim to the original process of the two methods. Similar same welding advantages shown in figure 1079 with rotating non-rotating pressure, rotating non-rotating pressure, rotating upset non-rotating pressure, non-rotating upset pressure friction welding process. Your advantages are friction welding can be produced with a high quality welds in short cycle time. No filler metals is required with the flux is not used. Process capable of welding most of the common metals, but also be with many of the combinations similar with the friction weld requires relatively expensive apparatus similar to the machine tool. Process principle: there are three important factors involved in making friction weld: rotation speed of the relay of the material to the weld, the diameter of the weld, the interface of the pressure between the two parts to be welded. Pressure changes during the welding. Sync with the start pressure with the very low, then increase with the create with the frictional heat. With the rotation stop of the pressure is rapidly increased. Forging takes place immediately before and after the rotation. Welding time is related with the shape and the type of the metal over the surface of the air with the normally matter of the few seconds of the actual operation. Machine automatically control the sequence control, which can be set in accordance with the welded schedule of time with the parts to be joined. Normal friction welding, one of the parts to be welded with the round with the cross section, not absolute necessity. Visual inspection welding quality can be based on flash, which curve around the outside parameter of the weld. The flash will usually extend beyond the outside diameter of the parts. Will curl around the back toward the part will have the joint extend beyond the outside diameter. If flash sticks relatively straight within the joint, it is indicated that the welding was too short and the pressure was too low. The spot was high, and these joints may crack. The flash curl too far from the back outside indicated that it was too long and the pressure was too high between the extremity of the correct flash shape. The flash is normally removed from after welding. Alright, your electron beam welding. Electron beam welding process produced with the columns metal with the heat of conventional with the high velocity electrons striking in the surface of the be joined with the heat generated with the workpiece of the bombardment of the dense stream of the high velocity electrons. Virtually all kinetic energy or energy of the motion of the electrons is transformed into heat upon the impact. Two basic design process of low voltage electron beam system with accelerating voltage of 30,000 volts to 60,000 volts range, and the high voltage system accelerating ranges from 100,000 volt range, higher voltage ranging some in the midst of the X-ray, then the lower voltage system. In X-ray, two of the beam electrons are focused in a target to either the tungsten or molybdenum, which give the off X-rays. Target becomes extremely hot and then must be water cooled for the welding of the target of the base metal, which observe the heat to bring in the molten stage. Electron being welded, the X-rays may produce electrical potential with sufficiently high in both of these systems. Electron gun and workpiece are housed in the vacuum chamber. The figure of the 1080 show the principal electron beam welding process. 1080 show the electron beam welding process show the transformer coil, high voltage filament, cathode, anode, focus coil. Equipment. There are three basic components of the electron welding beam machine: the electron beam gun, the power supply with the control of the vacuum work chamber, the working handling. Electron beam emits electrons accelerated with the beam electrons of the focus on the workpiece. Electron beam gun, similar to the used on the television picture. Electrons are emitted with a heated coil filament with the accelerated with the anode positive charge plate with the coil hole from the electron beam passes. Magnet focusing coil located beyond the anode focus on the detector of the electron beam. The electron beam welding and the electron beam is focused on the workpiece at the point of the welding. Power supply furnished with the filament with the current accelerating voltage can be chained with a different power input weld. The vacuum work chamber that must be absolutely airtight. Container is evacuated mechanical pump. The diffusion pump to reduce the pressure for the high vacuum working. Handling equipment is required to move the workpiece under the electron beam. Manipulate it is required to make the weld. Travel mechanism must be designed with the vacuum insulation for the normal grease and lubrications. Certain insulation varnishes, electrical rotors may volatilize in vacuum. Highly hermetically sealed motors or sealed gearboxes must be used. In some cases, the rotor and gearbox are located on the vacuum chamber with the shafts operating in another sealed bearings. Alright, your advantages. One of the major advantages of electron beam welding is the tremendous penetration curve with a highly accelerated electron hits the base metal with it penetrating slightly with the surface of the point, releases the bulk of the kinetic energy, turned with the heat energy. Additional heat brings the substantial temperature increase to the point of the impact with acceleration of the electron striking in the same place, causing the melting of the evaporation of the base metal with the craves metal vapor. The electron travel through with the vapor mass easier within solid metal. This causes the beam to penetrate deeper into the base metal. The width of the penetration pattern extremely narrow. The depth of the width can exceed the ratio of 20 to 1. Power to density increase for the penetration curve of the electron beam. The tremendous penetration character of the low heat input, heat affected zone in such a manner smaller than the arc welding process. Addition becomes almost parallel side welding. Negative distortion very greatly and minimized, but the cooling rate is much higher for many metal. The advantages, however, the high carbon steel, the disadvantage of cracking may occur. Alright, your process principles. Reason advantage equipment allow the work chamber to operate with a medium of the vacuum pressure for the system of the vacuum work chamber is not as highly and sometimes called soft vacuum allowed some of the contamination obtained with the atmosphere. 99.995% argon mechanical pumps produce a vacuum of the medium pressure valve level. Electron beam welding is initiated done with a vacuum. Because of the electron beam is easily deflected in the air. Electron beam collide with the molecules of air in low velocities, the direction, so the welding is not performed. In a high vacuum system, electron beam can be located at 30 inches from the way from the workpiece. The medium vacuum in the work distance reduced to 12 inches. The thickness can be welded. The high vacuum is up to 6 inches thick, while medium vacuum thickness can be welded is reduced to 2 inches based on the same of the electron gun power bolt source. Medium vacuum pump downtime is reduced. The vacuum can be attained with the mechanical pumps only. Medium vacuum pump mode electron gun is open to separate chamber separate from the work chamber. The small orifice where the electron beam travels. The fusion vacuum pump that can run continuously connected with the chamber containing the electron gun so that it will operate efficiently. The most recent development of the non-vacuum electron beam welding system, the system work area to maintain the atmospheric pressure during the welding. The electron beam gun holds housed in the high vacuum chamber. There are several intermediate chambers between the gun and the atmospheric work area. Each of these intermediate stages reach reducing pressure by measuring means of vacuum pump. The electron beam passes with one chamber through the small orifice large enough for the electron beam to small large volume by the air. By the means of the different pressure chambers, the high vacuum is maintained by the electron beam gun chamber. The non-vacuum system that can thus be used for larger weldments. However, the workpiece must be in position 1.5 inches from over the beam exit nozzle. Maximum thickness can be welded currently approximately 2 inches. The non-vacuum system utilizes the high voltage power system. Heat input electron welding is controlled with 4 variables: number of electrons per second hitting the workpiece and the beam current with electron speed, moment of the impact, and accelerating potential through C, diameter of the beam within the workpiece of the beam spot size, and 6, speed of travel of the welding speed. D. 6, the first for 2 variables, and 5, beam current, accelerating potential, even the establishing welding parameter. The third factor of the beam spot side of the relay with the focus of the beam. The fourth factor is a part of the procedure. Electron beam current ranges from 250 to 1,000 milliamperes. The beam current can also be low as 25 milliamperes. The accelerating voltage with a 2 range mentioned previously with the travel speed extremely high. Related thickness for the base metal of the other material thus must be controlled with the gun work distance. Alright, the beam side of the vary with the location of the fecal point with respect to the strip of the part with the penetration can be increased with the placing of the fecal point below the strip over the base metal with the increased with the depth below the strip of the deeper penetration will result. When the beam is focused on the surface, they will become a reinforcement. On the surface of the beam is focused above the surface, there will be excessive reinforcement. Width over the will be greater. Penetration is dependent with the beam current. With the beam current with increase, the penetration is increased with the other variable travel speed, and also the effects of the penetration travel speed increase with the penetration reduced. Heat is produced with the electron beam with relatively small compared to the arc welding process. With the power of the electron beam compared with the gas mount arc welding will be the same relative to the amount of the gas mount arc welding require high power to produce the same depth penetration energies in joules per inch. For the electron beam welded may be 1 to 10 as greater for the gas mount arc weld of the electron beam equivalent to shield model arc welding weld within less power with the penetration obtained by electron beam welding. The power density ranges from 100 to 10,000 kilowatts an inch squared. Welding joints of the electron beam welding must be selected with the care of the vacuum chamber. The welding special techniques may be used to properly align with the electron beam with the joint, but extremely narrow. The preparation for the welding joint must be extremely accurate. The width of the weld of 1.5 inch thick stainless steel would be 4/100 of an inch for the small misalignment. It would cover the electron beam to completely miss the weld. The joint special optical systems can be used to allow the operated to align the work with electron beam, and with the electron beam is not visible within the vacuum. The welding joint with normally used with the gas tungsten arc welding can be used with electron beam welding. The depth not to the width of the ratio special lap of the type of the joint with the joint fit up with the not precise ordinary lap joints used with them welded as arc seam to do. Type of the weld, normally with a filler metal, not used with electron beam welded. However, the welded mild steel with a highly deoxidized filler metal, and sometimes used with the help deoxidized molten metal produce dense welds. Or in the case of medium vacuum system, a much larger work chamber that can be used with the newer systems available. The chamber to seal the round part will be welded. In this case, the design specifically with the job of the hand. Latest using sliding steel with a movable electron beam gun, and other versions of the medium vacuum system can be brought into, taken out of the vacuum work chamber. The means of the interlock with the process can be made more or less continuous. Automotive industry using the system for welding gear clusters. Other small assemblies complete with the machine built part can be done since the distortion at minimum. Non-vacuum system finding a substitute for the other application with one or more of the productive application welding automatic catalytic converters around the entire peripheral of the converter. Electron beam process becomes increasingly popular wherever the cost of the equipment is justified with the production of many of the parts. Also used with a very great degree with the automatic entry industry, remote windows from the remote welding from the welding and refactoring metal. The electron beam welding is not a cure all. There are still possibilities of defects in weld of the process, any other. Many problems of welding on the plain carbon steel will channel that becomes porous and when welded in the vacuum metal. The melting metal releases gases originally in the metal, results of porous weld. The deoxidizers cannot be used in the process. Is not suitable. Our electron beam welding continued. Welding metals, almost all metals can be welded with electron beam welding process. The metals are the most often welded superalloys, refractory metals, Reactive metals and stainless steel. Many of the combination dissimilar metals can be also welded. R11, 1021, laser beam welding. We're going to cut the tape. Testing.